Hello everyone! I'm Ma'am Maria Sofia Rosa Arcalweng, Teacher 1 from Batasan Hills National High School. Here's a video guide for our mathematics lesson for the first quarter. In our first module, let us discuss and learn about factoring polynomials. Are you ready? Don't forget to watch and listen attentively to know more about how to factor polynomials. At the end of this lesson or video, you are expected to recall the process of getting the GCF of numbers and variables, enumerate the method of factoring polynomials using common factor, difference of two squares, and the sum or difference of two cubes. And lastly, factoring polynomials completely using common factor, difference of two squares, and sum or difference of two cubes. Let us now discuss the first lesson under Module 1, Factoring Polynomials with a Common Factor. But before we proceed on our discussion, let us recall the concept of the greatest common factor, or the GCF. Can you still remember the GCF? Greatest common factor, or the GCF, of two or more monomial is the product of all the prime factors that are common to all the terms of the polynomial. The GCF contains the lowest power of each number and variable that occurs in any of the terms. Let us have the first example. What is the GCF of 18 and 27? So for us to get the answer, we will list down all the factors of 18 and 27. So let's start with 18. What are the factors of 18? So we have 1, 2, 3, 6, 9, and 18. How about the factors of 27? So we have 1, 3, 9, and 27. After listing all the factors of 18 and 27, look for their common factors. So based on the list, their common factors are 1, 3, and 9. But remember, we are looking for the GCF, or the greatest common factor, of 18 and 27. So among all their common factors, the greatest is 9. Therefore, we can conclude that the GCF of 18 and 27 is 9. Next example. What is the GCF of 6a and 3a squared? So notice on this given, it has already a variable. So what are we going to do now is to find their prime factors. So let's start with 6a. So what are the factors of 6a? So we have 2 multiplied by 3 multiplied by a. Let us check. 2 times 3 is 6 times a, 6a. Next, how about the prime factors of 3a squared? So we have 3 multiplied by a multiplied by a. Let us check again. 3 times a is 3a times a, 3a squared. So after listing all their prime factors, we need to find for their common factors. So as you can notice, they both have 3 and a. So their common factors are 3 and a. For us to get their greatest common factor, we need to multiply 3 and a. or their common factors. So 3 multiplied by a is 3a. Therefore, we can conclude that the GCF of 6a and 3a squared is 3a. Now, now, we are now ready to proceed on our first lesson, factoring polynomials with a common factor. But wait, how do we factor polynomial whose terms have a common monomial? So the first thing you will do is you need to find the greatest common monomial factor of each term of the polynomial. Next, factor out the GCF in the expression. And lastly, express the polynomial as a product of two factors. Let us factor now 2ab plus 2ac minus 2a. So let us first write or list the terms. So we have 2ab, 2ac, and 2a. And then listing all their prime factors, we have 2 multiplied by a multiplied by b. For 2ac, we have 2 multiplied by a multiplied by c. And for 2a, we have 2 multiplied by a. Now, since we list all their prime factors, we are now ready to get their greatest common monomial factor. So we will just write down or bring down all their common factor, which is 2 and a. So multiplying 2 and a, we have 2a. So the GCF is 2a. But that is not yet the final answer, since according to the steps, we need to express our answer as the product of two factors. So what will be these two factors? So for the first factor, we will write the GCF that we got a while ago. So we have 2a. So meaning we already have our first factor. For its cofactor, we will just write here the remaining factors, which is b for 2ab, c for 2ac, and for 2a we have 1. Okay, so for the operation used in between this term, we will be using the operation used in the given. So we have plus and minus. So b plus c and then c minus 1. Therefore, our final answer is 2a multiplied by the quantity of b plus c minus 1. Next example. Factor y raised to 5 plus y cubed. So again, list down all their terms and then get the prime factors. Y multiplied by y multiplied by y multiplied by y multiplied by y. And for y cubed, we have y multiplied by y multiplied by y. So again, for us to find the greatest common monomial factor, we have y, and y, another y. So we have y multiplied by y multiplied by y. So we have y times y is y squared times y cubed. So again, that is not yet our final answer because we will express our final answer as the product of two terms. So let us have the first factor, which is y cubed, the GCF. And for the next factor or its cofactor, we will write here all the remaining factors of y raised to 5 and y cubed. So for y raised to 5, we have y multiplied by y, so we have y squared. And for y cubed, Since you can't see anything, we will write 1. So the operation used is plus. So we have y cubed multiplied by y squared plus 1. Next example. So we have 20x squared minus 12. So we have here 20x squared and 12. What are the prime factors of 20x squared? So we have 2 multiplied by 2 multiplied by 5 multiplied by x multiplied by x. So for 12, the prime factors of 12 are 2 multiplied by 2 multiplied by 3. So getting their greatest common monomial factors, we have 2 and 2. So 2 multiplied by 2. And that is 4. So the GCF is 4. So again, writing down our final answer as the product of two terms. So the first term or the first factor is 4. And for the second factor, the remaining prime factors of each term, which is 5 times x, 5x times x, 5x squared. And for the prime factors, the remaining prime factors of 12, which is 3. The operation we will be using is minus, since the given uses minus. And that's it. So the final answer is 4 multiplied by 5x squared minus 3. Last example. The given is x quantity a minus b plus y quantity a minus b. As you can notice, this is different from the last examples. As you can notice, we have a minus b on the first term and another a minus b on the second term, meaning the greatest common monomial factors is a minus b. So how do we get, ma'am, our final answer? So it's the same. Write your final answer as the product of two terms. So we have a minus b as our GCF, and for the next factor or for its cofactor, we will write the remaining terms, which is x and plus y. Therefore, our final answer now is quantity a minus b multiplied by x plus y. Let us now proceed on the second lesson under Module 1, factoring the difference of two squares. Looking back on your grade 7 lessons, you multiplied binomials, right? So for instance, we have here quantity a plus b multiplied by quantity a minus b. So based on the definition, the product of the sum and the difference of two terms is the square of the first term, which is a, and the square of the last term, which is b. So out of this concept, we will now apply how to factor polynomials in this pattern, which is the difference of two squares. Before we proceed, let us recall the product of binomials using FOIL. So, I have here quantity x plus 3 multiplied by x minus 3. So, multiplying these binomials using FOIL, we will have, of course, we need to multiply first the first term. So we have x multiplied by x is equal to x squared. The outer term, so we have x multiplied by negative 3. So we have negative 3x. Next, the inner term. So we have 3 multiplied by x. So we have 3x. And lastly, the last term, which is 3 multiplied by negative 3, and that is negative 9. Combining like terms, so as you can notice, negative 3x and 3x are like terms, so just add it up. If you add negative 3x plus 3x, it will result to 0, so we will just get the remaining terms, which is x squared minus 9. So this is our answer. On this time, we will reverse the process. You will be given the difference of two squares, and you need to find the factor of it. So how do we factor polynomials using difference of two squares? So the first thing you will do, you need to identify the first and the last term in each expression. Second, get the square roots of the first and last term. Lastly, write the factors as the product of the sum and difference of the square roots of the first and the last term. First example, factor x squared minus 100. Make sure that the given is a difference of two squares. Make sure that the sign or the operation used is minus and the two terms is a perfect square number. X squared is a perfect square since its exponent is divisible by 2. 100 is also a perfect square number. So now, since we checked it and it is a difference of two squares, we are now ready to get the factor. So first, identify the terms. So we have x squared and 100. Second step, get their square root. So the square root of x squared is x. The square root of 100 is 10. Now, for the last step, let us express our answer as the product of the sum and difference of the first term, which is x, and the second term, which is 10. So our final answer now is quantity x plus 10 multiplied by x minus 10. Next example, 4x squared minus 36. So again, check if it is a perfect square number. 4x squared is a perfect square number or term since 4 is a perfect square number and the exponent of the variable is divisible by 2. 36 is also a perfect square number. So let us write it down. 4x squared and 36. Next step, get their square roots. 4x squared, square root of 4x squared, and square root of 36. Square root of 4x squared is 2x. Square root of 36 is 6. Now, let us express our final answer as the sum and difference of the first term, which is 2x, and the last term, which is 6. Therefore, our final answer now is quantity 2x plus 6 multiplied by 2x minus 6. Let us have the last example. 9x squared minus 64y squared. So again, check if it is really a difference of two squares. 9 and 64 is a perfect square number. Check. The exponent used by x and y is divisible by 2. Check. The operation used is minus. Now, let us write the terms. 9x squared and 64y squared. Get their square root. The square root of 9x squared is 3x. The square root of 64y squared is 8y. So again, we will express our final answer as the product of the sum and the difference of the first term, which is 3x. So that will be your first term. And then your last term, which is 8y. So our final answer now is quantity 3x plus 8y multiplied by the quantity of 3x minus 8y. Let us now discuss the third lesson under the Module 1, factoring the sum or difference of two cubes. But before we proceed on our discussion, you must recall the cube of a number. It will help you a lot if you can still remember this. For example, what is the cube or what is 3 cube? Is it 9? No. So that is 3 multiplied by 3 multiplied by 3. So that is 27. Another example. What is 5 cube? Is it 15? No. That is 5 multiplied by 5 multiplied by 5. 5 times 5 is 25 times 5, 125. Another. What is the cube of 10? Is it 30? No again. So that is 10 times 10 is 100 times 10, 1000. So 27, 125, and 1000 is a perfect cube number. So when someone asks you what is the cube root of 27, that is 3. What is the cube root of 125? That is 5. And what is the cube root of 1000? That is 10. The question is, how do we factor polynomials using sum or difference of two cubes? Keep in mind that your factors must contain a binomial and a trinomial. The binomial factor must consist of the cube roots of the first and the last term. Take note of the sign of the last term. The trinomial factor must have the square of the first term of the binomial factor as its first term. The second or the middle term is the negative product of the binomial factors. And the last term is the square of the last term in the binomial factor. For our first example, we have x cubed plus 1. So again, keep in mind that your final answer here must be a product of a binomial and a trinomial. So what are we going to do first? Let us focus on the binomial. So what will be the first and the second term? So for us to get the first and the second term of the first factor, we will be getting the cube root of the first term on the given. So the cube root of x cubed is x. And then get the cube root of the second term on the given. So the cube root of 1 is 1. Therefore, the first term on this binomial is x and the second term is 1. Take note of the operation used on the given because that will also be your operation on the first factor. So your first factor is x plus 1. How about the trinomial? So we will be getting the first, the second, and the third term. So how? You will get first the squared of the first term of your first factor. So your first term is x. What is the squared of x? So that is x squared. For the second term, you need to find the negative product of the binomial factors. So, negative, what will be your first term? X. What is your second term? 1. So that is negative. Negative times x is negative x times 1, negative x. Next, for the last term or for the third term, get the squared of the second term of your first factor. So what is the squared of 1? And that is 1. Now, you will write all these terms inside these parentheses. So x squared minus x, and since 1 is positive, we will be writing plus 1. So the factor of x cubed plus 1 is x plus 1 multiplied by the quantity of x squared minus x plus 1. Next example, factor 27a cubed plus b cubed. So again, our final answer must be written as the product of a binomial and a trinomial. So again, let us focus on the first factor, which is a binomial. So we have first term and second term. So for us to get the first term, we need to get the cube root of the first term of the given, which is 27a cubed. So cube root of 27a cubed is 3a. Very good. Next, for the second term, we will be getting the cube root of the second term of the given, which is b cubed. So cube root of b cubed is b. So now we will write as 3a as the first term and b as the second term. And again, the operation used on the given is plus. That's why your operation here is also a plus sign. Next, for the trinomial, so we have the first term, the second term, and the third term. For the first term, we will be getting the squared of the first term of our first factor. So the first term of our first factor is 3a. So the squared of 3a is what? So that is 9a squared. And for the second term, again, we will need the negative product of the binomial factors. So negative 3a multiplied by b. And that is negative 3ab. And for the last term or for the third term, we need to get the squared of the second term of your first factor. So that is b. Squared of b is b squared. Now, we will write all this term inside again of the parentheses. So 9a squared minus 3ab, since b squared is positive, plus b squared. So our final answer is 3ab, 3a plus b multiplied by the quantity of 9a squared minus 3ab plus b squared. So let's have our last example. So we have 64p cubed minus 8q raised to 9. So again, our final answer must be the product of a binomial and a trinomial. So again, let us first get the first term of our first factor. So we will get the cube root of 64p cube, which is the first term of the given. So we have 4p. And for the second term of our first factor, we will be getting the cube root of 8q raised to 9, which is the second term of the given. So the cube root of this one is 2q cubed. And now we're ready to put it here on our first factor. So again, take note of this. Whatever the operation of the given will also be the operation to be used on our first factor. And for our next factor, for the first term of this one, we will be getting the squared of the first term of your first factor, which is 4p. So we have 16p squared. And for the second term, we will get the negative product of the first and the second term of your first factor. So we have 4p and negative 2q cubed. So we have positive 8pq cubed. And now for our third term, again, so like what we did on the first term, we will be getting the squared of our second term of the first factor. So we have negative 2q cubed, quantity negative 2q cubed squared. So we have positive 4q raised to 6. So we have 16p squared for the first term. Next, positive or plus 8pq cube for the second term. So let me erase this one kasi may it will not fit. Okay? Next. And for the last term, we have plus 4q raised to 6. And that's it. Our final answer is 4p minus 2q cubed multiplied by 16p squared plus 8pq cubed plus 4q raised to 6. Activity time. So prepare all your papers, prepare all your folders for our activity. Please refer to your module on pages 9 and 14. Thank you.